Hello everyone, we will solve this today's LeetCode problem. This is a LeetCode medium one. Let's see what the question is. The question is subarray nums divisible by k, right? So we have given an integer array nums and an integer k. Return the number of non-empty subarrays that have sum divisible by k. Oh, that's the same question which we have solved previously. Uh, it is the same question. It's the same question as yesterday's problem. And that is the same question as yesterday's problem. Yesterday's problem, right? In that problem, we need to return false, true and false, and here we need to find the number of sub-arrays. We find their true or false. We find their true or false, and here we need to just find the number of non-empty sub-arrays that is divisible by k, and here we need to find here we need to find the uh, total number of non-empty subarrays, right? Non-empty subarrays, right? So it's the same problem, right? It's the same problem, and so let's see. The question is like, let's see the first example. So if you have not watched that previous videos, you should watch it. That's the same question, subarray sums divisible by k. I will put the link on the I button, right? So let's see how this will be solved. This is the same that will be the same approach. If you have solved the previous problem, it is you just need a simple uh, changes to solve this problem, right? So let's see. So here 450 minus 2 minus 3 1 is given, and k is equals to 5 given. Okay, one thing here is not to note is that here it is given negative numbers also, right? So for finding the negative numbers, what we need to do, we need to just take this problem, right? So if we say for k is equals to 5, for divisibility condition for 5, so what would be the condition? 4 plus 5, right? So 4 5 0 minus 2 minus 3 and 1, right? So if we see about 4, it's 4 divisible by 5. No, it's not divisible, right? Again, if you see, if 4 plus 5 9 is divisible. No, it's not divisible, right? Again, if we see, is not, if so here if we see this 4 and 5, right? So is 5 is divisible. Is 5 is divisible. So one sub-array is 5, right? One sub-array is 5. Now 4 5, if it's 0 is divisible, so 0 is divisible, so 0 can also be sub-array. But if you see, this 50 can also be a sub-array, right? So here we see three possibilities are there. Three sub-arrays is possible till now. Minus 2 is divisible. No, it's not divisible. Minus 3 is divisible. No, it's not divisible. But if you see this part, minus 2 and minus 3 is both divisible. Minus 2 minus 3, if you sum it, its summation is minus 5, which is divisible by 5, right? Which is divisible by 5, right? So we need to handle this negative numbers. In this case, we will see that how we will handle. So, and if you see again, this 0 minus 2 3 is also divisible, right? 0 minus 3 to 3 is also divisible, right? If you see again, 5 0 minus 2 3 is also divisible, right? Because its summation is 0, so it is also divisible. And if you check, this whole subarray summation is also divisible. Its whole summation array is also divisible. So if you see, total 7 number, seven subarrays are divisible. So answer is 7 here, right? Answer is 7 here. So if you see, if you have solved this previous problem, the question is of now that how we will determine that how many subarrays are there, right? So now if we look it again, we need to find all the subarrays, right? We need to find all the subarrays. So for checking the divisibility condition, what we need to do, we will check for each number. So what I will do, suppose, see, we need to ultimately take the summation, right? We need to ultimately take the summation. But if you take a number and submit it again and again, like 4 5, then 4 5 0, then 4 5 minus 2, then 4 5 0 minus 2 minus 3, then start from 5, so that will take O of n square. That is also not optimal solution, right? So for taking summation, what we need to think of that we take summation at one time and use that summation to find the total number of sub-arrays which is divisible by this k, right? So let's see how we can do that, right? So if I start taking summation, if I start taking summation, so in starting this is 4, and starting this is 4, so I will take summation of 4, right? Now again, after taking this 4, if I start take summation of with 5, it becomes 9, right? It becomes 9. So it 9, this 9 is divisible by 5 or not? No, it is not divisible by 5, because k is equals to 5 here. So we will see for k is equals to 5. So this 9 is divisible? No, it's not divisible, but it is greater than this 5. So what I will do, I will take the modulus of that, because for if the number is not divisible, it will be if the number is, if the number is not divisible, not divisible, its remainder, its remainder will be between 0 to k minus 1, right? Between 0 to k minus 1, for sure, right? And if you also know that if to make that number divisible by something, we need to add this remainder, or we need to remove this remainder, for sure, right? If I need to make this that number divisible by k, I need to remove that number. So what I will do, I will store that number. So what I will do, this 4 plus 5 is 9, so I will take the modulus of 5. So if I take modulus with 5, it becomes 4, right? And if you see, this 4 is already been occurred at previous, where this here, at previous position, this previous position, this 4 is already occurred. So what does that mean? It means if the remainder is occurring again, if the remainder is occurring again, it means between both of the indices, both of the remainders, there will be definitely, there will be definitely, definitely summation of all summation of there will be definitely a sum of all elements occur, elements where the sum is divisible by that k, divisible by that k, divisible by k. This is the meaning of when we get the same remainder. So it's the same thing, that if you get the same remainder after taking modulus of summation, it means between both of the remainders, the summation of elements must be divisible by the k. That's why the remainder becomes same, because when you add the number, when you add the some numbers, it should increase. But if number is not increasing and it is same as the previous number occurring, it means the sum of all the numbers must be become zero at some point. That's why, because we are the motto of taking modulus is, taking modulus is that if the number if the sum is divisible at any point, divisible at any point, at any point, then the summation would not get affected, right? Not get affected, and the and after some time it will give the same remainder, right? And if the after the motto is of taking modulus is the same, that at any point the summation would get affected, would not get affected, sorry, would not get affected, right? By divisible by k, right? At any point then the summation would not get affected. If the summation not get affected, it means we got something, we got really we understood that we will we have a divisibility summation of all elements, definitely a subarray between those remainders which have which are divisible by this k. Understood, right? So this 4 is already occurred previously, it means we got a subarray, we got a subarray, definitely, right? So what I will do, I will store a count, right? Now again, when I start summation this 4 with 0, this will again 4. Now when this 4, and if you also see in this 4, this 5 is divisible, in this 4 this 5 is divisible, that's why it just occurred at previous position, it just occurred at previous position. So when this 4 when again take summation with the next element, it again become 4. Now this 4 occurs two times here two times, right? So the total number of subarrays will be 2. Why? If you see this 4 occurs two times, it means there would be a 2 subarrays possible, where the summation of between the elements would be divisible by k. See, this 50 is also divisible, and this 0 is also divisible. That's why for 50, this 4, after this 4, this 50 occurs. That's why this 5 this one occurrence of this 4 occurs, and for this 0, this 5 is divisible, for this 0 is divisible. That's why this 4 occurrence. So these two parts, if these two parts tell us that this 4 is occurring two times, it means there are two scenarios possible, right? So what we are doing, just storing we are just storing all the numbers or reminders which occurs previously, right? All the count of numbers or reminders which occurs previously. So what are we doing? So this 4 is occurring, so I will store this 4 in my anything. I take a hash map or something, right? I will take a hash map or something for storing. You can take anything, whatever you want. I am taking hash map for counting, right? So this 4 is 1. Again this 4 occurs, so I will take 2. Now again this 4 occurs. So for this 4, how will check that this 4 is occurring? By seeing this, that this 4 is occurring, and how much time? This 2 times. So what I will do, I will just include this 2, right? Now this 4 occurs 3 times now, so I will make this 3. Now again I will go to -2. Now here you need to see something. This 4 and this -2, this is a negative number, right? So when you take summation, it becomes 2. When you take summation, it becomes 2. So here the summation get decreased, the summation get decreased. But when you take this modulus with 5, it becomes 2, right? But this is a negative number. So for when you take modulus, when you when you take modulus of negative numbers, you need to must add you need to must make that number positive before taking modulus, before taking modulus before taking modulus. Because the why? Because when you want to take remainder of when you want to take determine the remainder of anything, you must take. So for making positive number, what we need to do, we will we will simply add k in that number, right? We will simply add k in that number, right? Or 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 take absolute value, or take absolute value of that number simply. Either you can take simply add k, or take absolute value of that number. So this is -2 is given, so either you can make it this as 2 and then take modulus, or either you will simply take modulus of this -2 modulus 4, which is equals to -2, modulus 5, which is equals to -2, and then you will add just 4. This becomes 2, right? This is a positive number, so we don't need to do anything right now, right? We don't need to do anything. So this become -2 now, right? So if this becomes -2, it means this -2, 4 -2 plus 5, 4 -2 plus 5 becomes 7. So this will become 7. For this minus 2, what I will do, I will just do 4 -2 plus 5 which is becomes 7. And when I take this 7 modulus 5, when I take this 7 modulus 5, it becomes yeah, it becomes 2, right? So for that, it becomes 2, right? Or either you can do that 4 minus 2 is 2, right? Ultimately you need to make this number as positive, right, by taking modulus. That's what the motto is here. So either you can do this, or if you getting 4 minus 2 is positive, it means you are good to go, right? So 2 is here now. Is 2 occurs? No, 2 not occurs. So I will just include this in my store this remainder in my answer. Now 2 minus 3 is minus 1. 2 minus 3 is minus 1. But taking modulus of minus 1 is what? Nothing. So what I will do, I will just include this in 2 plus minus 3 plus 5, which is equals to 7 minus 3, which is 4, right? Which is 4. Oh, sorry. Yes, this should be 4. 2 minus 3 is 2 minus 3 is 4, 2 minus 3 is 4, minus 1, which is when we add 5, that becomes 4, right? Yeah, correct. Minus 3, 2 minus 3 plus 5, which is will become 4, right? And when we take this modulus with 5, it becomes 4 again, right? Now this 4 again occurs, and previously the 4 occurs also there. It means we need to include between all these, uh, between this 4 and this 4, this this would become a subarray. Between this 4 and this 4, this would be also a subarray possible. Between this 4 and this 4, this subarray is also possible, right? So it means three answer can be possible after this 4, right? So we will just include this 3, right? Now after this 4 plus 1, which is now equals to 5, and when we take this modulus with 5, it becomes 0. It becomes 0, but 0 is not available here. But 0 is not available here. Why? Because we haven't added 0 till yet. But if you see, we have an array of we have an array of just a minute. Yeah, we have an array which is summation, this 4 5 0 minus 2 minus 3 1. If it is occurring 0, it means definitely we have this subarray which is divisible by 0. It means we just need to initialize initially 0 with 1. Why to include this 0 with 1? Because at any point, if my summation of after taking modulus is becoming 0, it means we definitely have a subarray. We definitely have a subarray. So for that, we need to initialize with 0 with 1. That's just an implementation part. So that's why this, if this 0 occurs, so it occurring one times, so I will just include 1 again. So it becomes total 7, right? This 450 minus 2 minus 3 1 is divisible by 5. So if it is 0 occurs, it means I will need to check either it is present or not. I will just initialize with 0 with 1, and this becomes 7, right? This is just an implementation part after this. So this is how we will solve this problem. Yesterday's problem was what? Yesterday's problem was that if any subarray occurs which is divisible by a summation of divisible by the k, and its subarray length will be I think at least 2. So that would we need to just return. So we have approached we have taken the same approach. We are just taking the same approach, but making some changes, like this negative number should be before taking modulus, this should be make positive and then take modulus, right? The reason being that the number should be between 0 to k, right? Not less than 0, right? That's the reason. The number should be between 0 to k only, because remainder is only the remainder will be only 0 to k minus 1, right? It can't be negative, right? Remainder can't be negative. So let's just take approach, final approach. What we are doing, we are we are taking start taking summation. We are start taking summation from starting, and before, and we take modulus of we take modulus of numbers. We take modulus of sum, and if it is and if the number is negative, and if the number is negative, then we will make it positive. And then we take modulus of sum, right? We use we use we use HashMap for storing this sum value, sum occurrences sum occurrences. If the same remainder or number occurs again it means we definitely got subarray. We definitely got a subarray, right? We definitely got a subarray. We definitely got a subarray. Uh, we definitely got a subarray, right? So yeah, we definitely got a subarray. And how many subarrays? The number of the occurrence, the number of count, the count of occurrences, count of occurrences, and the counts of occurrences of that remainder previously, right? That must the subarrays, and we will just store our answer. We just store that in our answer, right? So this is the whole approach we follow here. That's the same approach. We need to make some changes. So let's try to implement this, right? Just try to implement this. So what we need to take a summation value. Also, we need to take an answer value for storing the answer. Now I will take an unordered map for that, for storing the occurrences. Now we will iterate in this nums array. Right? Now I will iterate in this nums array. I will start taking summation. Right? I will start taking summation of this. So now, if you see what we are doing, we are we will start taking summation of the numbers. If it is a positive, then we don't need to do anything. But what if it is a negative number? If it is negative, it means I need to make it positive. Then we will take it as we need to make it positive for finding the remainders, right? Remember. So for that, what I will do, I will just take the sum and add this number. But before adding this number, I will take the modulus of that. I will take modulus of that. And now after adding the summation, I will again take a modulus, right? I will again take a modulus of that. But before taking modulus, I need to add the sum plus k modulus k, right? So if it is a positive number, then this sum plus k will not get affected anything, but because this k will modulus k becomes 0, and this summation will not affect. But if it is a negative number, it will become positive. Suppose the sum becomes -1, so -1 plus 5 becomes 4, which is 4 is a the 4 is a positive number, and by taking modulus it becomes again 4. But if it is greater than number, but suppose this sum becomes -10, right? This sum becomes -10. So suppose this sum becomes -4 or something like that, and if we add this k, so before taking this modulus part is to make this number between 0 to k, so that by adding this plus k, it becomes between 0 to k. So our motto is to we just need to make the summation between between 0 to k, right? To make this summation 0 between 0 to k, after taking modulus, we take modulus this, and then we add this k if it becomes negative number, so that it becomes the positive, right? That's the whole motto of this part. Now what I will do, simply, if my count if this sum is available in my count, I will just add the number of occurrences. Otherwise, I will just simply add here, right? I will just simply add it. That's the simple answer here, right? So if you see, this part is this implementation part is just same. Okay, one thing we we are missing. You think of that, what we are missing here. Okay, if you think, good. If you don't, just remember that we need to include this mp0. Remember, this need to be initialized with 1, or you can write it like this. Both is correct. You need to initialize with 1. Why? Because you see here, this 0, if 0 is occurring any part, it means we got definitely a subarray, right? Either 0 is occurring before or not, because this 0 represent that number is divisible by k, right? So I need to include this mp0 1 in start initialization. Now that the implementation is successful, We need to store every summation value, every remainder which is occurring again and again, and ultimately I need to return an answer, right? So this is how we will implement it. Just run it. I hope I have not made I have not make any compilation error. Yeah, so I have not made. Let's submit it. Yeah, we have passed all the test cases successfully, right? Now the time and space complexity. So time and complexity will be the same as previous. So we are taking O of n for iteration and all, and this amp.count just take O of 1 for fetching, right? Hash table. So that would be O of n only, O of n only, and the space complexity would be. So what will the space complexity? So the space complexity would be, yesterday I have told you wrong that O of n, that ultimately it will be O of k only. Why? Because we are taking modulus this sum, right? We are taking modulus this sum. So this sum, the sum value would be, the sum range would be only from 0 to k. This would be only from 0 to k, or 0 to k is this is excluded. This is excluded. This is excluded, right? K is not included, so it will be 0 to k minus 1 only, right? Because we are storing sum after taking modulus. So the space complexity would be at max k, right? It will be at max k. So that this time the space complexity here. I hope you have you have successfully you have understood, right? So thank you so much. Hope you liked it. Bye bye. Thank you.